Good day, dear honorable judges. We are the Team Tech Titans from SMK King George V. We name our project C-Xylanase-The Natural Paper Bleacher. I'm NICSON Yap.
I am SHAMAN.
Paper bleaching with chlorine leads to serious environmental problems. Our project asks, can agricultural waste, specifically corn husks, be used to create a natural and more eco-friendly bleach? Next, research focuses on producing C-Xylanase using moldy corn husk solution. Xylanase, an enzyme found in herbivores and fungi, break down plant material. Our project, molds growing on corn husk leaves naturally produce this enzyme, which we then use to de-ink paper during recycling. Xylanase enzymes are great for making pulp brighter and stronger, and they are made using either bacteria or fungi. The bacteria are a bit better because they can produce enzymes that handle heat and high pH levels more effectively. Now, mold on corn is a big issue, and fungi like Trichoderma, Penicillium, Fusarium, and Aspergillus can cause it. Some of these fungi produce toxins that can harm animals, especially cattle. So, we need to be cautious when deciding to harvest or to use corn with mold. That's why it's important to test for these toxins before making any decisions. The process requires high pH and temperature, and Xylanase producing microorganisms thrive in these extreme conditions. These enzymes reduce the need for toxic chemicals, making bleaching cheaper and more eco-friendly. Interestingly, corn husks, a low-cost agricultural waste, are great for producing these enzymes. Trichoderma species like Trichoderma longibricidum are good at this, and Cladosporium and Penicillium strains have also shown promise. By using waste materials like wheat husk, we can optimize production and lower costs even more. Sustainable Development Goal 12 aims to ensure that we use resources efficiently, improve energy use, and promote sustainable infrastructure. It's all about managing what we have responsibly so future generations can benefit. Our project aligns perfectly with SDG 12. We are contributing to responsible consumption and production patterns, creating sustainable solutions and helping to build a greener future. Moving on to the objective of our project. The aim of this project is to produce a cheap and effective natural bleacher to replace commercial chemical bleachers using paper recycling plants like chlorine.
The materials used to make this natural paper bleacher are corn husk, chlorine, C-Xylanase, frame for making recycled paper, and plastic container.
The first step to preparing this natural paper bleacher is preparing the extracts. Figure 3 and Figure 4 show corn leaves being cut into small pieces, and the small pieces are then used to obtain the extract. The collected corn leaves are then blended and extracted to be prepared for the next step, which is vacuum filtering. Next, we have to filter and concentrate the extracts. Figure 7 shows the extracts being vacuum filtered, and Figure 8 shows them in centrifugal. The extracts are then pipetted into a millipore tube as shown in Figure 9. Figure 10 shows the extracts in the millipore tubes. A centrifuge machine is then used to centrifuge the extracts as shown in Figure 11. The concentrated extracts are then obtained after the centrifuging process. Next, the preparation of agarose gel for radiodiffusion. Figure 13 shows the materials needed for the preparation of agarose. We first need to measure the mass of xylem from beechwood needed to prepare the agarose gel. Next, we have to mix 50 ml of 0.1 mol sodium citrate buffer that has a pH value of 5 with xylem. The mixture is then poured into petri dishes. Fourth step is radiodiffusion. First, we need to make wells in the solidified agarose gel. We have to pipette 18 ml of each extract into the walls of the agarose gel. Figure 20 shows the solidified agarose gel filled with 18 ml of different extracts such as sterile water, corn leaves extract, and pure Xylanase. As shown in Figure 21, we have to incubate the agarose gel containing the solutions at 45 degrees Celsius temperature. The final step is the preparation of the recycled paper. Figure 22 shows the pulp from all newspapers, and Figure 23 shows the wooden frame mounted with wire mesh that acts as the container. The final step, as shown in Figure 24, is pressing the pulp on the wooden block to produce a piece of recycled paper.
Ladies and gentlemen, in this experiment, we measured the brightness of paper, which refers to how much blue light of a specific wavelength is reflected. Brightness is evaluated on a scale from 0 to 100, where a paper with a brightness rating of 95 reflects more light and therefore appears brighter than the one rated at 85. Ideally, we would have used a laboratory paper brightness meter color test machine to measure this. However, as this equipment was unavailable, we utilized a lux meter app. Lux measures illuminance, which is the amount of light cast on a surface, essentially representing light intensity in a specific area. These are the results of the comparison of brightness of 3 pieces of recycled paper. The brightness was measured in lux as indicated under each image. Figure 25 shows recycled paper A, which was not treated with any bleaching agents and had a brightness of 21 lux. Figure 26 presents recycled paper B, which was bleached with chlorine, showing a slight increase of brightness at 23 lux. Finally, figure 27 shows recycled paper C, which was treated with a C-Xylanase bleach alternative and recorded a brightness of 22 lux. Ladies and gentlemen, this chart presents the brightness levels of the 3 recycled paper samples. As shown, recycled paper B, which was treated with chlorine bleach, recorded the highest brightness at 23 lux, while recycled paper C, treated with the C-Xylanase bleach alternative, had the second highest brightness at 22 lux. Ladies and gentlemen, in conclusion, C-Xylanase proves to be a good alternative compared to traditional chemical bleachers. Furthermore, the production of C-Xylanase for bleaching recycled paper is not only practical and affordable, but also eco-friendly. By using corn husk, a common waste product, as a medium for mold growth, we are able to transform waste into a valuable resource. This directly aligns with the United Nations Sustainable Development Goal 12, which emphasizes the responsible use of resources. Through this project, we demonstrate how waste materials like corn husk can be repurposed for more sustainable and eco-conscious production processes. These are the list of references. Lastly, we would like to thank our mentor, Madam Gan Bin Hoon, and lecturers from INTI International University for assisting us throughout this project. We would also like to thank Malaysia Young Scientists Organisation for organising this competition. With this, we thank you.